All electrical wirings in houses are connected in parallel. The advantages are that each electrical component can be switched on or off separately. All the electrical components receive the same amount of voltage, and when one electrical component fails, all the other electrical components can still work. But the greatest drawback of parallel circuits is when more electrical components are added, the effective resistance decreases, leading to an increase in the current. This is because the effective resistance of a parallel circuit is given by the formula. The inverse of the effective resistance is equal to the sum of the inverse of the individual resistances. As an example, when we have one bulb with a resistance of 500 ohm, the effective resistance is 500 ohm. When we have two identical bulbs in parallel, the effective resistance decreases to 250 ohm. When we have four identical bulbs in parallel, the effective resistance decreases further to 125 ohm. As more electrical components are added in parallel, the effective resistance decreases considerably, resulting in a large surge of current. This will produce a lot of heat in the connecting wires, causing the insulation to melt and burn. In the past, this was not a big problem because there were not many electrical appliances in a common household. But nowadays, we have air conditioners, ovens, waffle makers, toasters, rice cookers, washing machines, water heaters, hair dryers, televisions, computers, the list goes on. To reduce the risk of electrical fires, electrical engineers have introduced the distribution panel. Instead of one large parallel circuit in the house to connect all the electrical components, several smaller parallel circuits are used, each connecting a few components. This is why homeowners are advised not to use extension boards, because the extra electrical components may overload that particular parallel circuit and cause a fire. Instead, it is advisable to employ a certified wireman to add a new circuit from the distribution panel. In the distribution panel, each parallel circuit is protected by a miniature circuit breaker. When an electrical component shorts, only that circuit's breaker trips, cutting off the electricity supply to just a few components. All the other circuits will still function. Back in the 1940s to 1970s, one large circuit breaker protects the whole house, and if one component shorts, the whole house will be without electricity.